look at the tension. So basically what is tension? Tension is a force. Tension is a force. We consider like this is a bob, like this is a bob, and it is connected with a string. This is connected with a string, right? And you know that the weight will be acting downwards, so the force which is acting upward, that is known as tension. So what is tension? Tension is basically a force exerted by a body with the help of a string, that is called tension, right? The SI unit of tension force is Newton, and the direction of this tension is away from the contact point. The direction is away from the contact point. Like how? Like consider that this. Here you can say this is the contact point, right? So the tension is moving away from the contact point. So this is the force exerted by a body which is tied to a string, that is known as tension, and it is a SI unit is Newton. So let's look at, basically there are two cases of tension, and number one case is case number one, when two bodies are moving vertically, right? When two bodies moving vertically, move vertically. Like consider that here we are having, this is a pulley, right? And here we are having a body which is M2 basically, and here it's another body, right? So this is known as body A, this is known as body B. This is known as M1. The mass of this body is known as M1, and the mass of this body is known as M2, such that mass of M1 is greater than mass of M2. The condition we are having is the mass of M1 is greater than the mass of M2. So you can see that here the weight is applied. The weight is moving at this body downwards and the tension is upwards, right? Here the weight is downward and the body is moving upward, right? So here you can see that in body A, like we know that whenever the weight is greater, like you can say that this body A is bit lower than the body B. So it means the weight of body A is greater than the B, like it is given over here that M1 is greater than M2. It means there is a weight is greater than the tension. The case over here we are having, which is weight is greater than tension. So whenever, like there are three cases, whenever the weight is greater than tension and the body moves downward, the body moves downward. But what when the tension is greater than the weight? Then the body moves upward. The body moves upward. But when these both are equal, the body remains in rest. The body remains in rest. So you can easily see that in this condition in body A, the weight is greater. The weight is greater than the tension. So that's why the body is moving the downward. So you can see that weight is acting downward, right? Tension is acting upward, right? So here what we'll do, as we know that the weight is greater than the tension, then we will minus weight minus tension. So here this net force will be equal to, here our net force will be equal to weight minus tension, right? So you can see weight minus tension. Now we'll put these values, right? F net, we know that F is equal to ma, right? Here the mass was 1, right? So m1a is equal to, the weight is equal to mg, weight is equal to mg. So here m1g minus t. So this is the equation number 1, right? Here we are having this, right? Now let's look at the body B, right? Here we are having this body B. You can easily see that the weight is acting downward and the tension is acting upward. So over here, okay, the weight is acting downward and the tension is acting upward, right? So and the body is actually moving upwards. It means that the tension is greater than the weight. So it means that here tension, like here you can see this, net force will be equal to tension minus weight. We know that F is equal to ma, right? So here m2a is equal to T minus m2g. So this is the equation number 2, right? This is the equation number 2. Now we have to find the acceleration and the tension between this, right? So in order to find the tension, like if we first of all we will find the acceleration. To find acceleration, what we'll do, we will add, like if you want to find acceleration, you will add equation 1 with equation 2, but if you want to find tension, we will divide equation 1 with equation number 2. So here we are finding acceleration, so we will add equation 1 and equation 2, right? Now what was the equation number 1, right? Here you can see this. Okay, here the equation number 1 was m1a is equal to m1g. So when we are adding, the left hand side is equal to right hand side and the right hand side is equal to left hand side. Okay, left hand side is equal to right hand side. Okay, what was the left hand side, right, for equation number 1? So here you can see that m1a plus m2a is equal to m1g minus t plus t minus m2g. So this is what we got, right? Now what we will do is this minus t plus t got cancelled. Now what is the equation left? Equation left is m1a plus m2a is equal to m1g plus m2g. Now you can easily see that what's the common between these, right? What's the common? Here a is common, so a m1 plus m2, right? Here g is common, m1 plus m2. So what we have to basically find, we have to find the acceleration, right? So acceleration is equal to m1 plus m2, right, upon m1 plus m2 g. So this is the equation that we got. Okay, basically here you can see this plus will not come over here. Here it is minus, because you can see that here m2g was of minus, so here minus will come. So the equation formed will be minus, right? Okay, let me write in a proper way. minus m2 upon m1 plus m2 g multiplied by g. So this is the formula for the acceleration, right? Now if we want to find the tension, what we will do, we will divide equation 1 by equation number 2. Divide equation 1 by equation number 2, right? So here you can see this. Here we are having, okay, what was equation number 1? m1a divided by m2a is equal to m1g minus t divided by t minus m2g, right? Here you can see that the acceleration divided by acceleration, yeah, can also cut this. Now the thing we got is m1 upon m2. Here you can see m1g minus t divided by t minus m2g. Okay, by cm we can cross multiply this, right? Now what will happen is we'll get m2 m1g minus t is equal to m1 t minus m2g, right? When we will multiply this, we will get m1 m2g minus m2t is equal to m1 t is minus m1 m2g. So this is the equation we'll get. Then what will happen, will m1 m2g plus m1 m2g, like we will put this over here, right? Now it will equal to m1t plus m2t. Now what's the common between them, right? What's common? The g is common. Then m1, like here you can see these both are adding, right? So you can put 2m1 m2g over here, and what's common? T is common. Then m1 plus m2, right? Now what will form that t is equal to 2m1 m2g divided by m1 plus m2, right? So this is what we actually got, right? So here this is the answer. So I hope this case number 1 is clear to you. The tension is equal to 2m1 m2g divided by m1 plus m2, and acceleration is equal to m1 minus m2 upon m1 plus m2 multiplied by g. So I hope this is clear to you.